So now it's time for us to move to the next workshop session. So we have Manny from Polygon. He's a developer relations engineer at Polygon, who has a mission to empower and educate new and existing Web3 developers. Manny is a Web2 and Web3 developer with 14 years of experience in tech, working with startups to S&P 500 companies, and as a tech lead and a full stack web developer. So I'd like to invite Manny on stage. Hi, Manny.
Hello. Y'all can hear me just fine?
Yes, we can hear you absolutely perfect. So whenever you're ready, the stage is yours.
All right. I will start with this. All right. I don't know if we have like the chat, by the way. If you guys see the chat on the right-hand side, give me like a +1 if my presentation looks looks decent. There we go.
Many +1s.
Awesome. All right. So today we're going to be doing front-end to RPC. That's the presentation I'm going to be going over. This is exciting for me because this is a very, very new presentation that I worked on very late into the night, making sure that everything is working correctly and getting everything just up to buff. So we're going to be going over some fundamentals. We're going to be jumping into some code as well, and then hopefully jumping into some Q&A specifically for this presentation. So before that, just a little bit about myself. Ben mentioned a little bit about me, but I'm Manny, or you can find me on like almost any social platform as Coding with Manny. Feel free to follow me on Twitter. You can use this QR code to be able to scan it. So a little bit about myself. I'm a developer relations engineer, more specifically for the Europe region. So I'm responsible for technical talks, attending organizing conferences as well, and being able to create technical content for developers so that they have exactly what they need, whether or not that's Polygon products or Web3 or even Web2 kind of content. You can kind of see blogs, and you can see on Twitter that I post quite a bit in terms of different articles and different videos. I haven't pushed my YouTube channel out yet, but it's there. You just wait. It'll be coming. I have actually quite a few videos that are going to be coming out very soon, including a lot of topical conversations about ChatGPT lately, and how it relates to developers and how it kind of also kind of compares to Copilot for that matter. So definitely follow along if you want to. And like I mentioned before, I've been in the industry for probably technically 15 years now. Been around for a while, so I've been a tech lead. I've been quite a few different positions, and now I really do enjoy working at Polygon as being a developer relations engineer. So that's about me. Let's jump right into the presentation. We have a lot to cover, so I'll try to speed along as much as I can to be able to kind of get through, because I do want to get to the code portion of things to really give everybody a hands-on as to what you can do with this. So some of these things you might be familiar with. Some of these things there might be a little bit new, but hopefully we'll go over some understandings of how the blockchain kind of works with RPCs. So let's start off with like, what is an RPC? Okay, so an RPC is a remote procedural call. So if you're unfamiliar with, if you're unfamiliar with what a remote procedural call is, it's actually an API specification for extending procedural calls or functions. So whenever you hear procedural calls, you can actually interchange that with functions. So that just makes it so that you have a client and a server can communicate to each other via parameters. What does that mean? So that really means that it's just an easy way for you to call a function on a different server without having to jump through hoops. You can actually specify, hey, just give me this function on this other server or this other service that's not like native to me or whatnot that I don't have access to. I'm able to call that service or that function on a different server. So that's what a remote procedural call is, okay? So as I mentioned before, RPC is an actual API specification, right? But there's a few different API specifications that kind of exist in the market, and you might recognize a few of these, right? There's REST, GraphQL, SOAP, which is a little bit older, but as far as it goes, these are all API specifications, right? And I'm just going to dive into a little bit deeper as to what the major differences between each one of them are and what are some of the similarities. So one of the major similarities between like RPC, SOAP, and GraphQL is they only perform two types of methods: get and post. Whereas REST, you can do the full gamut of get, post, put, patch, delete, or whatnot in terms of HTTP requests. Another thing that's really unique with RPC, SOAP, and GraphQL is that they only have a single endpoint. So it's really action oriented in terms of the types of requests that you're making. So compared to REST, it's like resource driven. So in other words, when you're hey, I want to retrieve all users. I want to retrieve the users to-dos and whatnot. That would be more in terms of REST, in terms of the different collections and entities and resources essentially that you're kind of making requests for. When it comes to RPCs though, and specifically, you're calling the function. You're saying, hey, I want that function to be called, and I want you to get the results from it. So it's actually quite lightweight. It's very straightforward. Hey, if that function exists on that other service, that's the function that I'm going to call from another service for that matter. There's no, hey, let's figure this out, right? So some other differences between it is that RPC has some implementations also with JSON. REST does JSON. You can actually do XML as well. SOAP only does XML. GraphQL only does JSON. Where also there's another thing that differs between RPCs and GraphQL is that GraphQL does have, it seems like it's almost similar, but the major difference is also in terms of the JSON input for this specifically. So the way that GraphQL works is that you can do queries and mutations, and you can actually do batch types of requests to be able to pull in like a user's to-dos and their to-dos tasks and the items associated with that. You can go almost infinite, and sometimes that can be a problem for GraphQL in terms of the number of requests that you're performing. Where it comes to RPCs, you can do batch requests, but they're almost like in parallel in that sense. They're a little bit different, so you can't necessarily do it. And you might be able to configure in a way to be able to kind of go trickle down, give me users, and then their to-dos or whatnot. So it's a little bit advantageous though for RPC because it's a little bit more lightweight. GraphQL has a little bit more to it, and you have to define schemas is exactly what you need to do. It's kind of similar to REST. You have to define the actual endpoints and their relationships with each other. Whereas GraphQL, when it comes to RPC, whatnot, it's really, hey, this is the function I'm going to call, and these are some of the major differences between them. So there are some similarities and there are some differences, and I'm going to jump into also some use cases a little later. Okay, so why do I need to know this? Like, you're like, hey, okay, great, RPCs exist. Like, what does that mean to me? Hopefully what you get out of this is to actually better understand transactions and better understand how payloads go to the blockchain more specifically, right? So you might be familiar, quite familiar with different APIs, your GitHub API, Twitter API, they all use kind of REST, or they might use GraphQL. And a lot of the data that's sent over is in a human readable format, right? You can see that, it's a JSON object that I'm sending over. But a lot of the data that you send over to the blockchain is actually done in hash type forms in terms of the actual amount. So in this case, this specific hash actually represents this function called setGreeting and the input value of hello. So you hopefully at the end of this presentation, you get some value in terms of understanding like, hey, how did you get to that? And like, how do I understand these things? And maybe even you might have seen some of these transactions also on Etherscan or Polygon Scan for that matter, and being able to say, hey, there might be a way, how did they dissect that? How did they decode that in that sense? And hopefully be able to better understand that. And my ultimate goal with this is if you understand these things, these are actually the fundamental building blocks for a lot of requests to be able to interact with the blockchain. So, and there's a lot of libraries that are out there. There's actually a handful of different libraries that exist there. So if you understand these things, all those libraries are just an abstraction of what these requests are going through. And hopefully one day, if you do fully understand this, you might be able to contribute to the documentation. You might be able to contribute to open source projects in terms of improving the different libraries, or even come up with a new library yourself. It's really to be able to help the ecosystem as a whole so that you can kind of understand the basics of these different types of requests. So I am talking a lot about different types of backend, and we're going to be getting to the front end. So be patient with me. We're going to dive into some code. But first off, what we talked about was, okay, we have an API specification. RPC is our API specification, but there's different types of implementation of that for that matter as well. So an example of that is just like REST is actually an API specification. You can say, I want REST to be sent as just specific JSON. I can actually specify it to be XML if I wanted to. I don't know why somebody would do that. I can also specify it as HTML to be able to parse it as just text. Well, in this case, RPC has a few different standards that exist as well. JSON RPC is being one of those specifications or protocols that is known. And this is something that most EVM blockchains use, is JSON RPC to be able to allow communication to different types of blockchains or different types of EVM chains. It's quite widely adopted. I'll briefly talk about XML RPC. It's just, hey, it's an XML format version of RPC. gRPC is a general RPC that was developed by Google. I can't say too much, but they use a different type of payload to be able to do communications between different servers, but it's actually quite efficient. And there's tRPC, which is actually a new contender in the market a little bit, which if you're doing front end or full stack development, tRPC is a really interesting new type of protocol that you can take advantage of. And I'll cover that a little bit later if you're really interested. But know that, okay, here we're at JSON RPC. This is exactly what most EVM chains are using as a protocol, or it's defined, hey, we're dealing with JSON. So I will say protocol-ish in that sense, because there's a lot of Web3 companies nowadays that are using the word protocol like in their name for their company. And there is sometimes confusion as to what the definition of a protocol is. Personally, I think a protocol is HTTP, TCP for that matter. These are different types of protocols. So, but it sometimes can be derived as a protocol as a set of instructions to be able to define, okay, this is how you should do something, right? So even on Stack Overflow, it says, like there's some debate going back and forth in terms of is JSON RPC a protocol for that matter? RPC is not, so it's getting into semantics. So, but you'll hear me say protocol, just take that into a grain of salt in terms of it being protocol-ish. So let's look at JSON RPC specifically. There's actually a specification that defines how you actually perform JSON RPC requests, right? And it's actually really simple, okay? The way that there's really only like 3 different types of methods you can get from JSON RPC. You can get a response, like you can make a request and it's expecting 4 different attributes, right? The JSON RPC version, which we see here, the method, which is the method that you're going to execute on that actual client, or sorry, on that server, the transaction ID, so to be able to keep track of what transaction ID, and then the params in terms of a different payload that you might send towards that for the function to be able to digest, right? We get a successful response, which is returns back the version of the JSON RPC, the transaction, and then the result, which is the value of the outcome of that specific thing. Now, ID can sometimes be optional if you're doing a notify type request. But most of the time, if you're doing a standard JSON RPC request, even for blockchains, they ask you to specify an ID so they can keep track of those to be able to see what the result is. And then for errors, it's the same thing. It's just JSON RPC version, the ID, and then instead of a result, you show an error. And this is the format that you adhere to for JSON RPC. It's super simple. Now, I will say one thing I didn't mention before, just like GraphQL, JSON RPC returns 200 requests all the time. So if you get an error, it's just going to show up in the payload. You won't get 500 errors. You won't get 400 errors, things that are used to in terms of REST, where you can get like unauthorized, internal server error might be something that you could happen. But as far as it goes, you will always get 200 requests. So take that into account. You will also try to read the error messages, and you'll have to handle the errors gracefully yourself. But that's ultimately what makes it lightweight, is that it's really like, this is the format. That's all you need to remember. It's like really 4 or 5 fields, 4 or 5 attributes to be able to do JSON RPC and adhere to this. So let's look at an example of what JSON RPC and implementation of looks like. And I'm going to use a Node.js package to be able to do this, okay? Before we get on, give me whoever's still in the chat, give me like a +2 that you're like, oh my God, totally on board with this. I totally understand that. Or give me a -7,000, as in like, I'm totally lost on this. Okay. +2. Nice. Thanks, guys. +5. Okay, there we go. Over understanding. That's great. Okay, so I'll go into this. What I'm going to do is I'm going to create an HTTP server. I'm going to use Express. If you're familiar with Express, again, it's just a backend framework to be able to create APIs. So I'm using a package called JSON RPC 2.0, which allows us to adhere to the specific protocol or the standard for sending over that payload. So if we look at line 2, I'm importing Express. Line 3, I'm importing the JSON RPC server from JSON RPC 2.0. I'm creating initiating Express. And then I'm going to say, I'm going to initiate also a new JSON RPC server. I'm going to specify this on port 5001. I'm going to ensure with express.json that I can accept JSON payloads. That's on line 9. And then you'll see line 11, 12, and 13. These are actually how you add methods to JSON RPC. So all I'm saying is the server that I initiated from JSON RPC server, I'm adding methods and saying, this is the name of the method, which is echo. I'm expecting a payload of text, and I'm going to return text. Or in the second one for log, I'm just going to console log. I'm not actually going to return anything. And add method add 2 is just going to take whatever number it is, add it by 2, and return it in that sense. So it's not too far off from, if you're familiar with Express, like app.get or app.use for a specific endpoint. You're just doing it slightly differently. And then we have one single endpoint. If you look here on line 15 to 25, /JSON-RPC, this is a post request that expects any type of body. So we'll take on line 16, the actual request body. And from there, we're going to actually pass it to the server to be able to say, hey, we're going to pass the JSON RPC request to it. And then we're expecting a response. And whatever the response is, we're just going to, if I do get a response, I'm going to return it. So that's on line 20. If not, I'm just going to return a 204, as in like there was nothing needed to be returned. It was just blank. And it's pretty standard as in terms of most JSON RPCs. You might sometimes get some errors and say, hey, it's invalid. Depends on the actual RPC that in terms of the actual server and how they're maintained. But that's the server. There you go. You have like 3 different types of methods, and I'm just going to take advantage of them to be able to, I've already exposed them to be able to essentially do what I need to do on the client side. Okay, so I have my server, which is on my left side. That's the same script. Now I'm going to define a client, which is just a script. So what I'm going to do is I'm going to import the JSON RPC client, and the JSON RPC response is just a type that I'll need because this is written TypeScript. So there's some things I need to take advantage of. Next, I'm going to import fetch from Indici. If you're unfamiliar with Indici, it's like if most people are using node-fetch, you should be switching over to Indici because it's the new version of how you should be doing fetch within your node servers. So it's works the same way. You can actually do requests. It's a little bit different. It's just done in a more effective way. They had to rewrite it instead of actually rewriting how HTTP requests were done into Node. They actually created a new package, and that's what Indici is. So all I'm doing here is line 5. I'm defining the server. I'm going to define the client and like how I process different types of requests. So every request that are going through, we can see from line 8 to line 15 is just a fetch request with a post, content type application JSON, and I'm just going to pass in the payload as stringified JSON in that sense. And on line 17, I'm going to wait, hey, I want the JSON payload to be returned. If it's not a 200 or if the word error is in it, I'm going to throw an error with the status text. And then you'll notice that on line 23 here, what I'm doing is I'm doing client receive. Notice I'm not doing any return in this sense. You can kind of think of it, the way that they've set this up is that client receive is actually a callback. So all I'm doing is saying client receive, passing the data, I'm calling the callback to be able to pass it on. And the same doing on line 25, it's the same thing. I'm just passing it as an error response that we would expect in terms of that's being processed. So let's look at what an example is. I've set it up to be able to utilize my client for the client side. So configured it in that sense. So here's a basic client request that I would perform to my server, to the server RPC. So I just say here, my const result echo. I'm going to await client, which we defined before, request. We're going to request the function name, which is echo, and pass in the values or the parameters that adhere to what we see on line 11 here, which is text. And we're passing in text with hello world. Now you'll notice that like what we talked about before, adhering the idea of like, hey, a JSON RPC request needs to have the version number, the ID, the method, and the params. This actually is formatting things in the background. So that's where I commented out in line 4 to line 9. This is actually what it's being sent. The version number, the ID, and the echo, the method, and then the payload that it's sending towards it. And then I'm just going to echo out the results, console log out the results, and you can kind of see that the response is just going to be JSON RPC version, the same ID of that transaction, and then the result, which will be the other attribute that we talked about, which is just one of 5 that you have to remember. So it's quite simple. Like in terms of, you can actually add also middlewares to this, but as far as it goes, whatever the function name is on your server, that's essentially the function that you're going to be calling on your client. And you're just formatting in the way that adheres to the JSON RPC format. So this is, there you go. You guys have established or built a JSON RPC server and a JSON RPC client in terms of that's adhering to the JSON RPC specifications. Now, if you do want to know take a dive into this a little bit more, I definitely recommend looking at the repo that I just published. It's called JSON RPC example. It has the client, it has the server, it even has instructions how to set this up, and even has some additional validation and has some batch requests. So you can kind of look through that. I'll be posting the links in the end of the resources. So if you did scan the QR code at the end, like, you'll get all the links to all the repos as well to this, so that you can also dive in and take a look at how JSON RPC looks like from a node perspective. All right, so that's, we've essentially built a JSON RPC service that a client makes requests to on a backend JSON RPC server. Okay, so let's recap the differences between JSON RPC, REST, GraphQL in this sense. So JSON RPC has a specific format. REST can be any format it needs to, and GraphQL is defined by the schema that's defined by the user in terms of, or the dev or the backend devs who are deciding, hey, this is the schema that we're deciding on. JSON RPC has a single endpoint. REST has multiple endpoints. GraphQL has a single endpoint. For JSON RPC and GraphQL, they have get and post methods. REST uses the full aspect of things. And for batch requests, like I mentioned before, they kind of do them in parallel. So you can actually send multiple JSON RPC requests, but you have to do it in the same format, but just as an array. And that's the only difference in terms of batch requests. So it's done in parallel. REST, unfortunately, doesn't have an essence, an idea of like batch requests. And this is one of the detriments to it. And actually what kind of came to the invention of GraphQL was being able to make multiple requests to load up a page, so that you didn't have to make multiple requests where like, hey, I got to get the user ID, and then with the user ID, I need to get the to-dos, and I get all the to-dos IDs, and then from the to-do IDs, I get the items. It just makes 3 or 4 different requests, and it makes it a lot longer. So this is where GraphQL, you can do batching in any forms, which makes it a little bit easier. Now, I did mention that there's actually another contender, which is TRPC. So TRPC is actually a lightweight version or alternative to GraphQL. So you notice it can handle any JSON format, right? So almost like REST, it can handle, it only has a single endpoint. So similar to RPC, it only accepts 2 different types of methods, and the batching it can do nearly identical to GraphQL in that sense. So you might be thinking like, well, why aren't people using TRPC then, for that matter? Well, the reason why is that TRPC actually is set up to work with monorepo specifically. So if you have a team that has a backend that's different from, Node.js for that matter, or not in JavaScript, GraphQL will probably be your best bet in terms of a solution for that. If you're a full stack dev and you're building out like from the back end to the front end, I definitely recommend looking at TRPC, because it not only it gives you the best of both worlds, but it also gives you the type safe factor, so it's natively that whatever types that you generate on your backend, you can actually pull in from your front end much easier as well. So everything is type safe, everything is consistent, and it actually makes your development a lot easier if you're doing a full stack with a monorepo. And if you do want to learn a little bit more about TRPC, I do have a video about this as well that I did. It's a 2-hour workshop, so definitely check it out. I did it for Developer DAO, and I go over how you can use TRPC with signing with Ethereum, what it looks like as a separate backend API and a front end to be able to kind of build on top of that and interact with it to be able to get signed in with Ethereum working as an application too for authentication. So definitely check that out. Again, the links will be at the end for the resources. Okay, so what do some of the big guys use? And by big guys, I mean the big chains like Ethereum and Polygon, okay? So they do use JSON RPC as they adhere to that spec, but they don't use Node.js for that matter, okay? What they actually use is a Golang version or implementation of JSON RPC. And they use a version of it called Go Ethereum, or Geth for short, okay? Which allows you to be able to interact with the blockchain. So this is for any transaction that we're doing with your wallet, any transactions that we're doing in any form, we're actually using Geth as a JSON RPC to be able to perform requests on the blockchain, okay? Now, it's important to note that Bohr on the Polygon side of things is actually just a fork of Geth with some additional functionality for the Polygon POS, which is the proof of stake network, right? So all you get, it's essentially the same. So you get all the same methods. So ETH.request for accounts, all the same requests on Geth and Bohr exist, and for most EVM chains actually exist as well. So if you're using any EVM chain, you might see the same standard in terms of the same JSON RPC request for Geth in that sense. It does take a little bit to set up. You can definitely build your own node to be able to set up, to be able to make transactions and be able to make requests to the blockchain in terms of reads and writes, right? But as you can imagine, it actually is pretty expensive to establish. And this is where RPC or node providers come in, and you're like, okay, well, if I could build my own node or I can build my own RPC, like why would I need node providers like in Fura and QuickNode and Anchor and Alchemy for that matter, right? Well, the reason why is it can actually be really complex, and it can take a lot of time to be able to maintain a server for RPC nodes, right? You're talking about like you have to download the entire ledger for most of these services. So there's a huge storage cap that you need. You need CPU, you need RAM, you need networking for that matter. And RPCs make our lives a lot easier in terms of interacting with the blockchain because they often are a get JSON RPC or BOR for that matter, with some additional functionality they bake in also for the JSON RPC to be able to handle multiple types of requests, queue requests, relay requests, handle load balancing, give you stats, and a lot more. So it actually, a lot of RPC or node providers are there to be able to make your lives a lot easier so you can start building on top of the blockchain. Now, I will say this, that a lot purists will say that you should spin up your own RPC node. And like from a security perspective, yeah, it probably, if you're really, really cautious, you probably should start looking at maybe setting up your own node to be able to interact with the blockchain. It's because you're not using any middleman service, etc. But you can note that sometimes those costs can come up to $100 to $200 a month just to be able to run these types of services. So think about that in terms of trying to interact with the blockchain as opposed to spending like $5, $10, or even some of these services are for free, like Anchor, where you can use some of the RPC provider. You don't need to sign up for anything. You can use their endpoint to be able to interact with the blockchain. So give me a +3 if I have you guys so far. Your retention is still good. Give me like a +3 in that sense, please, please. This is a lot of information. I gave myself a +3, but that I still have you. Okay, so we have completely understood the idea of like, hey, we have RPC providers. We could actually build our own nodes. We understand JSON RPC, etc. We understand how that format goes and how we interact with it, and how we could build a JSON RPC server, but not a full node in that sense. But we're going to get into a live coding section now. So this is, bear with me. This is I haven't done this live yet, so there's actually quite a bit to go over, but there's a lot to this. And what we're going to be doing is doing a live coding session that's just pure HTML and JavaScript. There's no TypeScript, nothing. You are going to just look at what is going on underneath the hood in terms of making these types of requests. Okay, so I'm going to jump over to my code here. So I have a repo that's set up, and let me know. Give me a +7 if you think I should increase the visibility on this, or give me a +6 if you can still read this. +7 increase, +7 increase. Okay. Give me a +6 if that's good, or should I make it smaller? +6, it's good. Okay, I'll try my best with this. This is quite huge on my screen. All right, so I'll start off just by defining what this is. This is a bare bones project or whatnot. All I did is I initiated a package.json. I have a publics folder, and the only package, I know I said I was just using HTML and CSS. The only package I'm using is a package called live server. And all that's going to do is just serve up my static files for my HTML and JavaScript. So let's start off by just creating an index.html, and we're going to test this out. And I'm just also going to bring in, just because I know that I don't want you guys to see me typing this entire time, because that would just be a waste of everybody's time. So I'm going to paste the format of this text here. We should see that it looks like just very, very simple HTML. And let me just make sure that I have you guys here so I can still see you. Okay, so I'm going to go pm run dev, which was our JSON, and we can see that this is what's showing up. It's a very, very basic static site. All it's showing is the HTML, and it's not referring to any CSS, not referring to any JS in that sense, because we're going to go through 3 different things. We're going to go through wallet connections, like wallet interactions, so connections, address chain. We're going to go through contract reading, writing, and logs, and we're going to go to deploying a contract. Yes, you can actually deploy a contract just with the bytecode in your front end without actually revealing any of your secret keys. You can do that specifically with MetaMask in the front end. So I'm going to show what that looks like too. So bear with me, there's a lot to go through. So give me a +1 if you're still good to go in terms of energy, because there's a lot of code to go through in this next part. +1, +1. No, nobody's ready for this. There we go. One person. There we go. Thanks, Ben. Okay. So what we're going to do is, I do like to style things up. I hate looking at HTML this way. So I am actually going to cheat a little bit and start to use, I'm going to just load in Chrome. And what I'm going to do is, let's move this over here, is I'm just going to add some tailwind to this to be able to make it look a little nicer, because I hate when things don't look nice. So the only thing I'm going to do is, there's a tailwind script. It works the same way as almost applying CSS. You'll see that here. I'm going to apply it to after the title. And we should see that our UI looks a lot cleaner in terms of, hey, it's just a little bit dark mode. It looks a little bit nicer. The fonts are nice. So we're going to start off with the wallet connection. You can see here at the bottom, it's /wallet. We don't have that directory set up. So we're going to start off with that. So we're going to go wallet, and we're going to create a new index.html file in there. Okay. And while we're at it, because we actually have all the other, we don't necessarily need all these others. So let's create these other folders. So there's a contract folder and there's a deploy folder. So I'm just going to create a contract folder and a deploy folder. And let's just add some index.html to it. HTML. This is why I shouldn't type. Okay, so I have my wallet. I'm going to scaffold out just a basic HTML, just so you guys can see what that looks like. So, oops, no styling. First of all, I'm going to go to my wallet, and this is what it looks like. So what you'll see here is basic HTML for, hey, a title, a description. We have a button with an ID called Connect Wallet, and then we have a code element which will just display the outcome of that connection. Okay, so if we've successfully connected, or if we've unsuccessfully connected, we should show the output there specifically. So this is, you'll notice that there's a scripts.js file that we're referencing. So we're going to create a new one here, scripts.js. And we're just going to verify that that is working correctly with a window onload. Yes, this is old school of just pure JavaScript. So we're going to go console log window onload. And if we look, it does not like, oh yeah, because it's scripts. Again, this is why I shouldn't type. We'll see that it's successfully onloaded. Okay, perfect. So you'll notice that for my code, I tend to add a lot of comments, and this is specifically to kind of separate out visually and to organize my documents. I do this on purpose. So you might see a lot of comments, and that's done on purpose. So the first thing we're going to do is I want to be able to get the element for this HTML button. So not here, but here under the wallet.index.html, I want the button wallet connect that's specified for this ID. So what I'm going to do is get the element. And what I'm going to do here is go button wallet document get element by ID, button wallet, which is the name of the wallet. And we can actually see that. We can just console log that just to be able to see that it's actually coming through. And we can see that it's referring to the button and it's coming through. So the next thing I want to do is actually add an event to this. And the event we're going to do is a click event. And I want it to be able to call a function once the click has been completed. So button wallet add event listener click, and it's going to call this function called on wallet connect. And like I mentioned before, I like to organize my documents with a lot of comments. So in here, these are going to be all my functions. In this case, we just have a single function right now, which is the on-click wallet connect. And what I'm going to do here is I'm going to wrap this in a console group, which makes it a little bit easier to kind of keep track of how the console logs are going through, because I want to be able to see the result. So if I load this up and I click that button, I should see on-click wallet, which is a group of console logs that I can kind of collectively organize in that sense too. Okay, so the next thing I want to do is I'm going to take advantage of, if I'm sure everybody's aware that when you have an Ethereum Chrome or any wallet that has any EVM-based wallet that is a Chrome extension for that matter, will actually inject code into your browser in that sense. And the code that it's actually injecting is an object called window.ethereum. We can take advantage of this because this is actually the method to be able to connect with your wallet and interact with it. And one of the things we're going to do here is say, hey, we want this user to connect to this site. So when they click connect, I want it to be prompted for the wallet to connect to the site. If they haven't been, if they've already been connected, then it'll just show the result. So let's just output what that looks like. And to take advantage of that, I'm just going to load in I'm going to create a const called accounts. I'm going to go await window.ethereum, window.ethereum request, and we're going to pass in a method, and the method is called ETH request accounts. And you kind of see this is actually very similar to the JSON RPC request because we're just specifying the method that we really want. And I want to do a console log of just the accounts. Okay. So let's reload this. And I want to make sure that I'm not connected to the site already. So I'm just going to go to my connected sites, remove this, disconnect. Let's refresh it. And I click connect. It's going to prompt me to connect. Once I connect, we can see that it console logs. This is the wallet that's actually connected to the site. So this is a basic JavaScript request utilizing just the object. We're not using any libraries, nothing. It's a very basic request to be able to get the wallet to connect to the site. Perfect. So the next thing I want to do is I want to know what chain am I on, because right now I am on Polygon, Mumbai. I could be on Ethereum for that matter, but I want to do, when I connect, I want to be able to get the chain ID to be able to identify which specific chain I am and what specific network I am. So to take advantage of that, I'm going to run another Ethereum request for Ethereum request method net version. Now, some of them have a ETH chain ID, but net version still works for a lot of other EVM. The method still exists on a lot of RPC, JSON RPC services. So let's try this again. I'm going to click connect. And we can see that the chain ID return is 80,001. Okay. And that's the chain ID specifically for Mumbai testnet. Now, if I tried to switch over to, let's say, Ethereum, and I refresh the page and I click connect, we'll see that the chain ID is 1 because Ethereum's network chain ID is 1 for that matter. Okay. So let's keep it back on Mumbai. Let's try this again. The next thing I want to do is I want to, let's say I'm going to completely disconnect from the site and I'm going to try to connect to it. But in this sense, I'm going to click cancel. Okay, there's no result that shows up here, but it shows up in the console log. I want to be able to take advantage of that. And the way I'm going to take advantage of that is to be able to show that in the UI is do it in a try catch. And like we mentioned before, in our wallet, I want to be able to display that in our code element for here. So whether or not it's a successful connection or whether or not it's a unsuccessful connection, I want to be able to show that there. So first thing I'm going to do is I want to be able to get that code element so beforehand, because I want to be able to set it off later, whether or not it's from the try successful or the catch in terms of the error. I want to be able to set what's in there. So I get the element. Next, what I'm going to do, I'm going to paste the try catch here. I have to paste the try catch because the try catch is so easy. And then what I'm going to do here is I'm going to console log the error. And let's just format this a little bit. So what I'm going to do here, and let's just comment this out, is if I go connect wallet, I go reject, we get our error in terms of the message that user rejected. But now what I'm going to do is I'm going to input this into the inner HTML. So when I go click connect and I go cancel, we can see that it's actually showing up in our HTML element now. And the last thing I want to do is be able to say that, hey, the wallet is successfully connected. Here's the wallet address, which is, remember that it was an array that was returned, and it's usually the first index of the array, and then the chain ID, so the network that we're currently connected to. So let's try this again. I click connect. I click cancel. I can see that the user rejected. I click connect again. I successfully connect, and we can see that my wallet address and my chain ID successfully showed into the UI. So again, we've successfully connected, interact with the wallet to be able to connect with just the pure window.ethereum object that it injects into the browser. And you have to understand that what's going on here is that these services right here from Ethereum mainnet, Mumbai, Gurley, Sepolia, localhost or whatnot, well, maybe not localhost, but all these are actually RPCs themselves. And these are RPCs mostly because if they're predefined, they're coming from Infura or Consensus for that matter, to be able to make requests. Now you can actually add different types of networks to this. So Mumbai is actually one of those networks that isn't added by default. And one of the services you can use to be able to easily add a network to is a service called Chainless. You can actually look this up any type of chain you want to. In this case, let's go Polygon because I haven't added it here. And I'll connect my wallet. It'll connect to the site. And then what I'm going to do here, once it's connected, I can actually add a network to easily prompt it and add it to this. And it'll confirm these are the details. This is the RPC URL that you were referring to. Remember, the JSON RPC that we were looking at, the URL was localhost 5001. In this case, it's an actual URL and an actual domain with the actual chain ID. If I approve it, we can kind of see now that I have added Polygon mainnet as a network to my wallet. So let's just switch back to Mumbai because Mumbai is free and I don't want to spend money on this. So we've successfully connected our wallet, what we did to this. We've successfully showed the wallet address and we've successfully shown the current chain ID. And all we're doing with is just pure JavaScript in terms of the requests, which are RPC requests directly to the wallet in terms of making those connections. Now, I'm going to do one thing because, again, like I mentioned before, I don't like when things don't look nice. So I'm just going to add Tailwind styling to this so it makes it a little bit nicer in that sense. So I'm just going to go to my wallet index.html file, paste that in there, and this should look a lot nicer. So when next it shows the wallet address and the chain ID. It looks a little bit nicer. All right, give me a +3 if you're still with me because we're still going. We got 2 more examples to go through. Give me a +3 if you guys are still with me. Nice. Okay, we got some +3s. Let's get moving on this. Okay, so the next thing we're going to look at is contract interaction. So this is actually the longest one. So stay with me on this one because this is really, really interesting in terms of being able to read from a contract, also to be able to write to a contract, and also be able to read logs from a contract. Okay, so I do have what I want to first start off is, like I mentioned before, scaffold out a basic application. And what that looks like, if we go back and we go to my contract reading, writing, and logs. Oh, I added the styling to this, but okay, that's fine. So you'll notice that in this, though, there is a couple new elements, right? We still have the connect wallet, we have the code that's there, but we have a new section called section connected, okay? And this is the thing that it's set to default where the display is none. And what that's doing is saying, hey, I want to hide this until the user is connected. So if I uncomment this out, we should see, hey, this is the contract address. I want to perform a function called get reading. I want to get the result from it. And I also want to do a contract write and be able to get contract logs from a specific contract and from a specific block. And we'll go over each one of these steps. This is a little bit longer, but as far as it goes, it's a lot to be able to take in. Okay, so the first thing I need to do is once I connect, I want to be able to display that section. So I'm going to add a new scripts file here. Yes. And in here, I'm going to start off with, like before, a window.onload. And I'm just going to make sure that it loads successfully. So console log, window onload, and we should see that it loaded correctly. Second thing I'm going to do is, like before, I'm going to take advantage of getting the elements of that specific button and then adding an event to it, which is the on-click event, on-click on wallet connect. Okay, we'll note we have to define the function for this. So everything is the same for this specific function, but we add like a couple different lines to be able to show that other section that once we're connected. So like I mentioned before, I like to create my functions with a lot of comments. So here I'm going to do an on-click connect. I'm going to get the element like we did before. I'm going to get the accounts. What's new here is I want to be able to store the wallet address in a global variable. Okay, and the reason why I want to do this, as well as the chain ID, is because I'll need this later to be able to interact with it. So I'll need to create a new section up here called wallet address and chain ID. Globals. So these are global variables that we're going to be referencing later, and we want to be able to store the chain ID as well as the wallet address. So once it's successful, this is what we've seen before. But the next thing we're going to do is on line 40 is that the section connected, we're going to get that element and we're going to remove the attribute of style. So this is just going to remove the display none. Once that's done, it's going to show everything. And then what I want to do is in the field, I want to input the contract address so that we can kind of display that. And we haven't defined the contract address, but I actually have a contract that has already been deployed. So add that to our global section, and I'm going to briefly show you what this contract looks like. So this is the contract, and it's deployed on Mumbai. Let's briefly look at what that looks like. So this is a contract. The contract source code is very, very simple in terms of Solidity contract. It's a greeter contract. It has a global, like a public string for greeting. When you actually deploy it, you actually have to specify the greeting as it starts, and then it'll emit a log of new greeting every time the greeting is actually updated. So we're going to take advantage of that, being able to read the logs. And what we're going to do is we are able to get the greeting, and we're able to set the greeting. This is very, very simple in terms of a Solidity contract. It's a getter, setter, and also some logs. Okay, and it's already been deployed to Mumbai. So this is the contract that we're going to be interacting with. Okay, so we have the contract address, and I want to be able to just display that contract address in the input. It's just for read only. It's just for show, and then make sure that we're also showing the section address connected. So let's do a connect. And we can see that the wallet address shows up, the chain ID shows up, and we can see that the contract address was inputted in the input field, and this whole section is now showing. Perfect. So now we're able to successfully connect. The next thing we're going to do is do a get reading. Okay. So let's do the on click get reading. So we actually have to go to the bottom here, and we're going to take advantage of the get reading button. Bear with me. So the button is button contract read. So that's, if we looked at the HTML file, we'll see that the contract read is the button contract read, and we're just going to piggyback off that and add an event listener to be able to click it and then make a request essentially to the blockchain to this contract to perform the get reading function. Okay, so I have my contract read, and the next thing I'm going to do is going to add a event listener to a function called click contract read. And that click contract read is going to be a little bit complicated. So I'll break this up into a few pieces. Okay. So the first thing I'm going to do is I am creating a new function, and I obviously like to add comments to be able to make sure that I understand that everything is working correctly. So let's just test this. I connected, I click get contract read, and you can see that it actually fires here. So the next thing I want to do is I'm going to do some things where I'm just going to, what I'm going to do is set a loading state, basically, to reset this. So this code section here, I want to be able to get it and then set a loading state. So all this is going to look like is when I paste this code, I'm getting the code element for contract read, which is this HTML element. I'm going to reset it, set the state to loading. And then what I'm going to do is I'm also going to say the button that's inside it, when they click that button of contract read, I want it to become disabled so that they can't click it again, so that it's going to wait till the request actually finishes before enabling it again. So here I click it, I click get reading, shows loading, this button is disabled, and the loading state it persists in that sense. Okay. So this next step, okay, what we need to do in order to make a request for this is we're going to still take advantage of a window.ethereum request. And the type of request we're going to make is called an ETH call. Okay. And an ETH call is different from another call called ETH send or send transaction. This is a read request, so it actually doesn't cost any gas. And you can, if you're familiar again with contracts, anything that costs money is really more just anything that has to mutate the state or write requests in a sense. So we're passing in a method, but like we did before, if we saw what JSON RPC had, we had params that we were sending to it. So in this case, we're going to pass it. It expects an array, and we're going to say, okay, I want to call ETH call on this particular contract, and we specify the contract address here. That's the first parameter that it's expecting. So to contract address. And then what I'm going to do is I need to set the data that I'm going to be sending to it. Okay. And the data I need to send it, and this is going to look a little bit weird, but I need to send it an encoded function. Okay. And like we saw before, the function that I'm trying to trigger is get greeting. But I can't just say, hey, get greeting and call that function. Unfortunately, it doesn't work that way with get, right? You actually have to encode the function with the whole parameter, so it makes a hash of that specific. Now, the issue is This is like one thing that I'm doing here. I said I was just going to be using native JavaScript and HTML, but I will need a library for this one. But I'm going to use this as a CDN to be able to get this in the format that's needed for the encoded function, okay? And there's a few things I need here. Like the first thing I actually need is that I need for the encoded function that I understand what the ABI file looks like. So at least understand the structure of the contract. So like we mentioned, like we saw before here, contract that's deployed, we went under contract and we looked at the ABI. Basically, this is everything that I need to know about the function to be able to define what are the inputs, what are the expected outputs for that matter, to be able to understand how to interact with it. So I'm gonna create that ABI as a JSON file, like a JSON object basically, that I'm gonna utilize because I have this already set up. So these are all the functions, like an input for greeting. There's an input for specifically set for events, for new greetings rather. There's one for get greeting, and there's another one for get greeting. So it just really defines the structure of the Solidity contract. Okay. Next thing I need to do, okay, is I need to be able to get the function that I'm going to be getting that I want to trigger from here. So there's a few different objects in this array of contract ABI. And the one that I'm really interested in is more just the get greeting one. So all I'm going to do is I want this specific object from that whole ABI file. And in order to do that, I'm going to just parsing in, like going through an array as an array map. I'm going to go get greeting is equal to contract ABI and find where the name is equal to get greeting. And we can see that here if I go get greeting, and I'm just going to comment out the ETH request. If we save this, I've connected, I click contract read, and we can see that I got the get greeting object, which has all the attributes that were in the ABI. The name, get greeting, the outputs, etc. So it understands how to take advantage of this. Okay, so in order to get it to hash the function in the way that we need to be able to, for Ethereum to process it, I actually need to use SHA-3JS to be able to load KitJack, to be able to arrayify certain elements. And there's a lot of different steps to it. Like you would actually I would probably need 3, 4, 5 different scripts just to be able to get this if I had to write it out from scratch. So instead of that, we're going to take advantage of only this from Ethers.js, be able to load it from a CDN, and from there be able to take advantage of a function, a utility where we can take an interface and actually encode a function data. And what I mean by CDN, if you went to CDN.js, we have one for Ethers. All we're going to do is we're going to copy this link and we're going to add it to the top of our index.html file. So we'll see that here, which I did. So I'm just calling that. And what that allows me to do is now, when I go my onload, I can actually go console log Ethers because it's become global. And we can kind of see that I have access to that object now because I just had the CDN kind of added to the index.html file. Okay. Whew, it's a lot to go through. Give me a +4 if you guys are still with me. +4, Jonathan, thank you. Ben, was there for me. +6, okay, lost. Or even more, perfect. Okay, I'll make time to be able to go over questions for this, but essentially we're now able to take advantage of Ethers, and we're gonna format the function in the format that we needed. So we have get greeting, but what I need to do is I need to be able to have it in a format for the interface. So I need to be able to say, use Ethers utils interface to be able to get it in the format that's needed. So we have the object, we're passing it through, and we can kind of see what that looks like in terms of what the interface looks. Really just setting in the format that we need to for the next step. So connect. If I click get greeting, you can see that it's setting an interface that's set up by Ethers.js. And this is actually performing a lot of different things. Like if we really jump through this, there's actually performing 3, 4, 5 different types of functions to be able to kind of parse this information. So the next thing is we want to get it in the final form, which is the encoded function. All we're doing is saying, we had this before, So we're just saying the encoded function is equal to the interface that we just created, encode the function where the greeter's name, and what was the greeter's name? The greeter's name was getGreeting, okay? See what that looks like, the full encoded function. See this now, click connect, I click getGreeting, and we can kind of see that the full encoded function is set to 0xFE50CC72. That is the encoded function name of getGreeting, just as a read. And we need to be able to send that to Geth to be able to get it in the format that we need to be able to get a response. So when you pass in the contract address, and we passed in, and pass in the encoded function. Okay. And we can actually pass in a third parameter here, which is latest. So after the request is made, I want you to pull in the latest data from this. So I'm going to go const result equal to await. And what I'm going to do here is I'm just going to console log it just to be able to see what that result looks like. Wallet, set getGreeting, and we see that we got also a hash as a result back. So we're going to have to interpret this as well to be able to see what that string is. And there's an easy way to do this. We're going to take advantage of something called hex to ASCII, because this is just a hexadecimal and we need to convert it into ASCII characters. And there's a helper function that you can look up on Stack Overflow. It's called H2A, or hex to ASCII. And it's really just this function here. And I'll just put it over top here under helpers. And basically it goes through the string, parses every one of the elements as an index, and gets the string format based off of that. I won't go into detail in terms, but it converts hexadecimals into ASCII characters. So now here, we'll see that we have our result. But what I want to do is have the parsed version of it. I'm going to go hexadecimal. I'm going to pass in the result. And let's try this again. So I connect my wallet. I get greeting. And we can see that the message that was returned was and another one, which is the message that I actually set for this contract before getting into this presentation. So we're able to successfully format it in a way to be able to send a read request, and we're able to format it in a way to be able to get the string format of what that looks like. So I'm just going to paste in what this looks like as the final result for this, because I want to be able to show this in the UI, so that if any errors show up, I want to be able to, it doesn't show up here in the console log. So over this, it's all the same things. The only difference now is that when I click get reading, it's just going to show here they're loading. And this was the original result. And this is what was parsed in terms of another one. So this is an example of the hex transactions going through. And this is actually pulling from our contract. Okay. This is a lot. I realize that this is quite a bit. So I will jump into the write request, because actually that's probably the most interesting. It's actually really, really easy. It's the same process. It's just a little bit different in terms of we need to add the payload that we're going to send to it. I'll go over that, and then I'll show you guys just briefly in terms of the UI, so you can take a look at this repo afterwards in terms of how this works too. So last thing I'm going to do, I'm actually just going to paste the entire functionality in here so that everything is working correctly. So I'm going to connect to my wallet, and I'm going to do a contract write. So hello startup weekend. And if we look at this, you set this up as a form. It's our form contract write. What this is doing is we're getting the value. We're setting a loading state like we did before and disabling the button once the transaction is started. We get our contract ABI. We're looking for that set greeting function. We're setting an interface, and then we're encoding the function. Now the difference here for the encoded function, you'll see the difference between the read is that the read just set the function name, but for the write, I have to pass the payload, and I need to pass it as an array where the value of the greeting message is passed through. And then this creates an encoded function with the actual payload. Everything is the same. So I get my wallet address, the contract address. This is new. This is where it comes from. The data in terms of it's encoded. And the method that I'm using this time is ETH send transaction, which actually costs gas to be able to perform. So let's try this. So I'm going to go set greeting. It'll prompt my MetaMask to be able to approve the transaction. I'll approve it. It returns the transaction hash, and we can kind of see what the state is of that specific transaction. It'll take a few seconds to load. And yeah, sometimes we have to like refresh it. Transaction is successful. Now, if we go to get greeting, we should see hello startup weekend. So we actually successfully perform an ETH transaction through an RPC request. And if you remember correctly if you remember how the Solidity contract is set up, we also have event mitters to be able to say, hey, we know whenever a new message is created, we want to also be able to create a new log event that's stored to the blockchain. And we can see that by first taking the block number, because here in the inputs, we see that I need to know from what block number. In this case, we'll just set it a little bit sooner. So from this block number to the latest, I want you to get the new greeting event. So it has to be in this format, and get that element and return whatever event logs that you get from this. So if we see that, we get the full transaction. And if I decode it, I'm able to see that the hello startup message was there, and it was set up for the event emitter, like logged, that it came from the sender, which is my address, and the message that was sent as well. And this is actually a way, if you're doing like blockchain in terms of Solidity development, a lot of times if you're setting things up to have getters and setters, you might not need to use a getter. You might be able to use an event log or an event transmit, so it stores to the blockchain so that you can reference later, so that you don't actually have to spend money in terms of doing getters, because it just becomes more and more expensive. Now, it does cost money for logs, but it's far more efficient in that sense to be able to set logs than do direct gets. Okay. So we're able to successfully get the logs. We're able to successfully write to the contract, read to the contract. So this is all that has to do with contracts. And I'm just going to paste the code for this, and I'm going to show you guys what it looks like to deploy a contract only with HTML and JavaScript. So in this case, I'm just going to add a scripts file again, so you guys can kind of see what this looks like. And I'm going to go back, go to my deploy contract. And what I'm going to do is connect. And this is the bytecode. And the bytecode is the code when you did your compile for your Solidity, it produces a bytecode. This is the entire contract in its entirety, from its functions, its variables, this entire thing. And I'm going to deploy a new contract just with the bytecode. And you'll notice I'm not revealing my secret key, none of that, none of my passphrase. And I'm going to click deploy. So what it's going to do is going to prompt me. It's going to take a couple seconds. This is the actual transaction to confirm that the transaction is processed. It doesn't necessarily mean it went through. Hold up. Second. And we've successfully deployed a new contract to Mumbai, only with the front end to be able to deploy it. So this is the entire process of being able to do writes, reads, deployments, logs, etc., only with pure JavaScript. And you'll notice that a lot of them are just windowed at Ethereum requests for either net version, request account, send transaction for deployments as well. This is the same process in terms of API JSON RPC requests that are performed to be able to do basic transactions. Okay, so if you do want to see this, I do have the code for it. You can dive in deeper. There's a lot to it with a whole bunch of comments, so feel free to look through it. You might be asking, like, how did I remember all these method names? There's actually a specification that's set up for this. So if you went to the Ethereum GitHub repo for execution APIs, it has the entire list of all the events, all the list of different methods, what they do. These same methods exist on Bohr, the majority of them as well. So they're all the same. They start with ETH underscore, whatever the method name is. These are all them. This is a documentation. This is actually a specification that for JSON RPC in terms of how you should document your methods for JSON RPC. And it's documented also a specification from something called OpenRPC, which is a standard setup similar to OpenAPI. If if you're familiar with OpenAPI, it's really a standard to be able to define documentation for like REST type API endpoints. And unfortunately, OpenAPI doesn't adhere to the same standards as OpenRPC, because if you remember, traditional REST APIs have multiple different types of endpoints, whereas our JSON RPC has a single endpoint, so it has to be done a little bit differently. In this case, there's a standard. I definitely recommend checking out OpenRPC, and the code for that to be able to generate these pages for the documentation is actually specified by OpenRPC, and you can actually generate this and take a look at the playground to be able to generate these files too. And the nice thing is that it's agnostic. Has nothing to do with blockchain. It has to do with just JSON RPC as a standard. So we have the same JSON RPC standards in terms of requests for MetaMask as well, and for most documentation that are performing JSON RPC. So in this case, you can use the same. There's actually documentation for MetaMask on how to perform JSON RPC requests to the wallet for different interactions as well, like we saw before, including signing signatures and more. So what about libraries? This is the last thing I want to talk about. There's definitely different types of libraries. There's like WAGMI, Ethers.js, which we saw. There's Web3.js, there's Wallet Connect, there's Family, there's Connect Kit, there's Rainbow Kit, whatnot. The thing that you need to understand is that all these libraries they do make it easier for you to interact with the blockchain, right? But the main thing to remember is that all of these are just abstractions of what we just did, of just basic RPC requests. And maybe they add different mechanisms to retry or just handle gas optimizations a little bit better. But as far as it goes, these are at the base what is happening underneath the hood for all these different types of services, right? And Ethers.js is actually an abstraction, and WAGMI is an abstraction of Ethers.js. And you can actually do things on the back end and the front end, the same types of requests for wallet interactions. And the only difference is on the back end, you wouldn't use window.ethereum because the window object doesn't exist. You would use Ethers.js to be able to do interactions on the blockchain too. But my hope is that you guys understanding these fundamentals of how to do these basic JSON RPC requests or whatnot for the blockchain will give you a better understanding of like, hey, actually, maybe something's not working with this library, but I know how to do that JSON RPC request. It's actually quite simple. I can perform the request myself, or give you the better understanding and say, hey, maybe I noticed that this is not working. I might be able to contribute to an open source project like WAGMI for that matter, or some of these others, to be able to say, hey, I know what's going on under the hood, or maybe I have a better idea in terms of how a library should be built to be able to interact with the blockchain and add a different implementation in terms of abstraction. So libraries are definitely important. I think that they're great. I do contribute to WAGMI myself, but I think it's also really, really important to understand the fundamentals of what's going down underneath the hood in terms of the actual requests and the payloads to be able to interact with the blockchain. So these are all the links. We have JSON RPC, OpenRPC, Ethereum JSON RPC execution API, Etherflow, which is an interesting tool to be able to test different RPCs, Chainlist, which we showed in terms of being able to add different networks to your wallet, the libraries I'd mentioned. Check out my Medium article to be a Medium page. I have different articles of being able to do different implementations of plain JavaScript with JSON RPC and the code repositories that we have here. So if you do want to see all these, definitely scan this QR code. You'll be able to have this entire presentation and all the links with it, and you'll be able to click through and follow along yourself. All the Git repositories, all the explanations, everything is there. Everything's been committed onto GitHub as well. And that is it for give your guys selves a +1 applause for standing through this entire presentation, because it was long, but it was I hope it was informative for you guys as well. So Ben, I don't know if you have time for questions because it went over a little bit, but
yeah, maybe we can do a quick one. So maybe posting questions, feel free to shoot it in the chat. Oh yes, Jonathan. Yes, feel free to unmute yourself if it helps. I think we got to give him some time.
WebGL and Unity. So if you want to interact with contracts, you will probably need some sort of wallet or SDK with it. I know that Anchor has one. I know that Third Web has one in terms of SDKs that you can kind of work with Unreal Engine and Unity to be able to interact with, because ultimately it's a wallet that you're going to be interacting within that service to be able to take advantage of an RPC to then be able to interact with the blockchain. So hopefully that answers your questions. I would definitely recommend looking at Anchor's. Anchor has a gaming SDK for Unreal and Unity for that matter to be able to interact with the blockchain. How does RPC compare to other inter-process communications methods such as Web3.js, Web3.py in the context of Web3? So underneath the hood for Web3.js and Web3.py is actually they are making JSON RPC requests. So as far as it goes, these are just libraries or abstractions of what those requests are that you just saw. So those standard requests that we saw, like ETH, request accounts, or ETH, well, that's specific to the wall, but like ETH send transaction, that's what's actually going on underneath the hood. And Web3.js and Web3.py, their whole goal is to be able to make it a lot easier for those transactions so that you don't actually have to write out, the full, hey, I need to write out this huge hex value to be able to send a transaction. You can just write a string and it just handles it on its own in terms of all the tools that it has built within it. So it's part of it, and Web3.js and Web3.py are just like abstractions on top of it that just utilize that in that sense. If written with Hardhat to interact locally, then later move to Polygon, does anything change on coding? Okay, so the nice thing, if you do like local development, is that not a lot actually changes, because Solidity, you have Solidity code in Hardhat. You do it on local. You can do it to Gurley. You can do it to Ethereum. You can do it to Polygon. You can do it to Mumbai. It's actually all the same Solidity code in that matter. The difference is just in terms of price, obviously. So because Polygon is a little bit cheaper, but you can also deploy to Mumbai for that matter. But as far as it goes, like it doesn't really change that much. The only thing you will change is like for your wallet interaction, you'll actually change this if you're deploying to if you're running a local node with like Hardhat, is that you'll just change this to local hosts, and you got to make sure that Hardhat is configured for that. So you can actually deploy and make those same requests, those Ethereum, like those JSON RPC requests directly to your local host, right? One thing I will say though is if you're using an RPC provider, okay, and like let's say you're using one of the proprietary methods, like, hey, I want to get all the NFTs of all owners for that matter. Sometimes those specific functions are only proprietary to that RPC provider and doesn't translate to your local host. So you wouldn't get the same interactions, because obviously that needs to connect to a live network, and if there's no live network because you're on localhost, then it has nothing to read. So it's also good to sometimes write native JSON RPC requests to be able to see what that looks like locally and to see that all the transactions go through correctly. Does this have a recording? I don't know. Ben, do we have a recording for this?
Yes, we do. We will put it on the Miro board. So after we process it, and we will just inform you guys on Discord. So
Awesome.
Is there any other questions for Manny before we end today's session? Give it a quick 5 seconds. 5, 4, 3, 5. Right. Awesome. All right. Thank you, guys. Thank you, Manny, first and foremost, for this very, very informative session. So I feel that I've learned a lot as well. So thank you so much for being here. And yeah, to everyone, we have concluded the first half of the workshops today. So the next half will be in slightly less than 3 hours, 2 hours and 45 minutes away. So on Gather Town, and this is Ben signing off.